Ebola is an incredibly infectious disease. In 2014, we had a situation where there was a complete eruption of that disease. And I think it caught the world and West Africa completely by surprise. We've had more deaths and cases than I'd ever seen before. Absolutely terrifying.
Problem is, how do you provide diagnostic systems in a country that has no electricity and no refrigeration and no clean water? Is it even possible to do that?
The way to diagnose Ebola is a centralized, sophisticated, developed world laboratory with sample preparation, pipettes, glove boxes, centrifuges, preliminary chain reaction machines. But they're many, many miles from the core of where our patients are. How do you bring all of that complexity out to the rural villages where the disease is happening? And that was the work that we did with SolidWorks.
You really need to have diagnostic systems that on the spot, in a reasonable period of time, you can figure out whether that person who feels bad has Ebola or malaria or chikungunya or Lassa fever or something else.
One of the things we did is to say, well, let's package this whole thing up, put it into a single box, and people can apply a finger stick of blood to one end and in a short amount of time get a result at the other end. Ebola yes, Ebola no.
The new molecular diagnostic platform that we've developed makes use of paper microfluidic technology and can diagnose a patient in under an hour, about 45 minutes, from a finger stick blood sample in to a result out. A nurse or a doctor will take a finger stick of blood from the patient and apply it to the paper reaction disk of the device. We then slide this wet piece of paper that contains the genetic information of the virus to the amplification zone. That act of sliding turns on a heater. The amplification step is important because it provides more copies, really, that tells us, yes, this is Ebola. Like a photocopy machine, but for DNA. When we slide to the third and final zone of the device, it allows us to wash all of those new amplified copies out onto what's called the lateral flow strip that will give us lines if the patient is infected with Ebola or not infected. That readout is very similar to a home pregnancy test. There are key elements where the biochemistry and the physical design of the device intersect. And it was there where I had most direct contact and worked most directly with the design team.
This device had been proven out on the benchtop in terms of science and R&D, so we thought SolidWorks is a natural tool to help us take all of those electronics, all of those chemistries, and packing it all in one very small package. This is SolidWorks' thermal simulation of our device, and we can essentially see how the device is cooling itself. So this shows natural convection where you see heat coming off of the device in this way. This is our critical area here. This is the paper disc where we have the sample, and it needs to hold it at 65 degrees Celsius for 45 minutes in order to create many, many copies. If we go too hot, we end up killing critical elements. If we're not hot enough, it won't make the reaction happen. We can take it and look at each critical area and essentially investigate the entire device. That's something that would take us a really long time to do in the lab. We'd have to put a temperature sensor on every little piece of material here. This device is always going to be used by healthcare practitioners who have gloves on. One of the critical aspects of that is designing a tactile feel bump to know when they're in first position, second position, and third position. SolidWorks really helps because very quickly we're able to determine what would take a very long time in the lab. One of the great things about SolidWorks is we were able to design this and then quickly print it through 3D printing, get a feel for it with gloves on, and then quickly iterate on the height of the bump. We went through 5, 6 different iterations the span of 4 weeks. When I first joined Diagnostics for All, I saw this huge potential to take this amazing science we'd been developing for many years through implementation. And so I thought the first go-to package was SolidWorks. I knew that that's one of the best methods that we could use in order to communicate and collaborate to implement the project.
We have the opportunity to produce diagnostic tests across a whole range of diseases, and that's incredibly exciting. We can do this over 5 years, or we can do this over 18 months. And SolidWorks allows us to accelerate that tremendously.